Hi everyone. This video is on 7F applications of parabolas, and you should have received these notes. So hopefully you've had a chance to print them out. I was going to go through now. Of course, we've been through a lot of this, how to sketch these, but of course now we're starting to look at applying them to sort of real-world problems. And of course, you might need to identify what values of a variable would be relevant in a given context. So let's get sort of started and actually get sort of talk about what I mean. Well, for example, we've got one here. Michael's a civil engineer and he's designing a model for a curved cable. So we're talking about this thing here, modeling this thing here. And it says that this has the equation h equals d minus 3 all squared plus 2. Well, you'll notice that, if I was to write in h is equal to d minus 3 all squared, a lot of these, we don't sort of use y and x anymore. So in actual, but if you like, this is like the y. Okay, so this is like the y, and this is in turning point form in actual fact. There's a turning point at, well, what does d have to be for this to be 0? Well, d would have to be 3, so there's a turning point at 3, and of course there's also the y part of the turning point is going to be here. So there's a turning point at 3, 2. Now, let's label our graph so you can see that for this, we're looking at the height, and the height sort of depends on the distance. And this distance here, in this case, it says that the distance is d is from the left pillar. So we're sort of saying that this is sort of like d is equal to 0 here. This is d. This is d is equal to 0. And of course, if I go 6 meters to the right, then that would be d is equal to 6. So we could do this just as per normal. Let's go ahead and, well, first of all, let's sketch the turning point here, 3, 2. So go across 3 and I go up 2. So that's going to look something like that. And let's go ahead and find not the y-intercept, it would be the h-intercept. But of course, we would do that by, so the h-intercept. So we're trying to find this point here. Okay, so the h-intercept, well, let d equal 0. So it's the same thing we're doing. Now, let's do that. Let's sub in d. So 0 minus 3, wherever there's a d, I'm going to replace that with 0. And as you can see, I'm having troubles with my pen. Like so. Now, negative 3 all squared is positive 9. 9 plus 2 is 11. Okay, so if you think about it, the y-intercept, or in this case, the h-intercept, is 11. And what you can see is that if I basically sketch that graph, it's going to come down here and it's going to turn. Now, of course, we're going to have to find, you can see this will go to sort of this point here at d equals 6, and we're going to have to work out, well, let's work out what the height would be at d equals 6. I'm going to be guessing that it's the turning point's halfway, so because it's symmetrical, I'm going to be guessing that it's going to be the same. All right, so it's going to look something like this. But of course, we wouldn't sketch all of those points because we're just looking for the distance left of the, right of the left pillar. So we really don't need this part of the graph. We can start there, and once you get, the right pillar is 6 meters away, so we can we can basically say that we just want this. Let's find this point though. Let's just make sure that this is 11. Well, when d is equal to 6, let's substitute that in. We can get the h is equal to 6 take 3 squared plus 2. Now 6 take 3 is 3 squared. 3 squared is 9. You can see there that's 11. All right, now, of course, we could answer some of these. What is the minimum height of this cable above the road? Well, you can sort of see that that's represented by the turning point. So the minimum height would be a height of 2 meters. And I guess, yeah, we've sort of sketched the graph. And as you can see, this is sort of like the left pillar, and this is the right pillar, like so. And I guess the height of each of these cables can be determined from the distance from the left pillar. Okay, so that's these guys here, which of course is going to vary with the distance from left to right. Okay, so these are the sort of style of questions you're going to be able to do. Just be aware that, like, no longer do you often have X's and Y's. In this case, the Y-axis is like the height, and the X-axis is like the distance from the left pillar. All right, so what we're going to be able to do is you're going to have to sort of define variables, in this case like D and H. You've also got to solve equations as you usually would, and also you're going to have to come up with suitable ranges for these. So let's have a look and try another one. All right, it says here a ball is thrown upwards from ground level and reaches a height H meters. So, let's change this to H. That would make sense. And where the X is, T seconds, let's change that from X to T. Okay, given the formula this, it's a sketch graph of the rule. This means that T is between 0 and 4. So let's go ahead. I'm going to go up by 2s. So that's 1, 2, 3, and 4. Let's go up in ones like that. And it says here that we want to sketch the graph. So you've really got to find these t-intercepts or the x-intercepts. Okay, so similar to finding the x-intercepts, y equals 0. In this case, x-intercepts, t-intercepts, h is equal to 0. So we want to solve this equation here. Now, you might have noticed that this isn't a trinomial, but we can factorize this because we have a common factor of 5t, and let's throw that out the front. 5t, and what would go inside the brackets? That would be 4 minus t. That's going to give me this guy. So, of course, how do I solve this? Well, there's two things. Either this equals 0, which gives me t equals 0. Okay, would make sense that t equals 0, the height would also be 0, and at t equals 4. Now we've found the the t-intercepts. You can see here, it's like finding the x-intercepts. There you go, 1, 2. And now this is a negative parabola because of this negative here. So let's go ahead and we're going to have to, it says, what is the maximum height? Well, the maximum height is, well, we're sort of looking at that, and we know that the turning point is halfway. So let's go ahead. We know that that the turning point is at t, not x. T is equal to, well, let's add those two together, 0 plus 4, and divide by 2, which of course is 2. And well, now we'll get that. That means that that's sort of like our axis of symmetry. That's where it turns. Now let's go ahead and find what that height is. So we can say that when t equals 2, when t is equal to 2, then we can go ahead and say that the height is equal to, let's sub it in, 20 times 2, so 20, my pen again. All right, I had to change my battery in my pen, so let's go up. So I've just substituted that value of t. T is equal to 2 in there, and then I've got 20. So let's go up 5, 10, 15, 20, like so. And as you can see, we've got at time time equals 2 seconds, it should reach a height of 20. Now let's trace a line between those, or a parabola, turns there, and as you can see, now that we've sketched the graph, we can go ahead and answer those questions. So it says, what is the maximum height? Well, the maximum height is 20 meters, and that occurs at time equals 2 seconds. And how long does it take for the ball to return to the ground? Well, we can say that it's 4 seconds because, of course, we've sketched that parabola and the t-intercepts where the h is 0, the height is 0 and 4. All right, so hopefully you're filling this in your notes along the way. Let's have a look at another one. This time we've got a path of a javelin, and it's given by this formula. Again, notice this is a negative parabola, so it's going to have a maximum turning point. And let's start sketching this. It says that we have that D is between 0 and 22. So, of course, we want to sort of, let's change this X to D, the distance. And this time, Y again is the height. And the height is going to vary on the distance. So, first of all, we can sort of say that the turning point is at, well, it's at HK. So in this case, the turning point is at 10 and 9. Okay, so we can mark that out, 10 and 9. All right, so that's going to be the maximum height. And let's go ahead and do that. So let's go up 1, 2, 3, 4, 5, 6, 7, 8, 9 is up here. Okay, and let's go up in, we'll make 1, 2, 3, 4, 5, 6, 7, 8, 9. Look, I might go up in, I might say that that's 5, that's 10, that's 15, and that's 20, and then we sort of go to 22, sort of somewhere over there. All right, so sketch the graph. You can see there that we've got a turning point at 10 and 9, so let's go ahead and mark that out. And once again, we've got to find those intercepts. Well, the let's find the d-intercepts. So the d-intercept, we have to let h equal 0. Okay, so it's the same as what we've been doing. We want to solve this guy here. Okay, now we also can sort of say that, well, we want to subtract 9 from both sides. So we've also got 9, minus 9 is equal to minus 1 over 16, d minus 10 squared. And let's multiply both sides by 16 now. Now, 9 times 16 is 144. Okay, so 144 is, we've got negative 144 is equal to minus d minus 10 squared. We can divide both sides by the negative, which gives us just 144 is d minus 10 squared. Okay, and then let's take the square root of both sides. We've got the square root of d minus 10 squared. It's just d minus 10, and that's going to be plus or minus the square root of 144, which hopefully you can see is 12. Okay, so now let's add 10 to both sides. So d is equal to 10 plus or minus 12. Now, if we go ahead and do that, you can see that we can say, look, 10 minus 12. Well, 10 minus 12 is negative. So you can't get negative distance, okay, because it's d meters is the horizontal distance traveled. So in actual fact, there's only one solution to this. So it would be 10 plus 12, which of course is 22. Yes, there is two solutions, but not in this case. It just doesn't make much sense, does it? So 22 is sort of somewhere over here. And this javelin basically comes up And technically, let's have a look at let's find the other intercept before we sketch this though. We can say that the other intercept, the h-intercept, is when d equals 0. Let's go ahead and find that. So we've got h is equal to, let's sub in 0 wherever there's a d. So we've got minus 1/16. 0 minus 10 squared plus 9. 10 squared is 100, so that's going to be negative 100 over 16 plus 9. And we're going to have, looks like we've got some fraction over there. Now 16, let's just quickly work that out. So you can see there that I've just changed 9 to a fraction. So 144 over 16 is the same as 9. So I've just sort of multiplied this by 16. 9 times 16 to get that as the fraction. So then I can add those two together. Negative 100 plus 44 is 44. 44 over 16. So that's going to be like, I guess, if you think 48 would be 3. 32 would be 2, so it's going to be sort of, if I'm going up 1, 2, 3, 4, 5, 6, 7, 8, 9, it's going to be somewhere between 2 and 3 and closer to 3. So let's sort of say there you go. That is the coordinate 0, 44 on 16, not quite 3, but it's greater than 2. And as you can see, this is, so think about it, if someone's standing up holding a javelin up in the air, it's going to be sort of between 2 and 3 meters high, the tip of the javelin, and as you can see, that basically is going to come down, and that is going to, we've now sketched the path of the javelin. And it says here, what is the maximum height the javelin reaches? Well, we've just done that by finding the turning point. That is 9 meters. And what is the horizontal distance does the javelin travel? And that horizontal distance there, we can see, is the is 22 meters. Okay, so it goes up in the air, goes up 9 meters high, and then 22 meters away is where it lands. All right, so look, as you can see, we get the, it's the same principles, it's just you've got to turn those words into and give them some meaning by looking at these in a slightly different context. All right, so now let's go through another one. This time we've got a piece of wire measuring 100 centimeters in length. It is bent into the shape of a rectangle. Now we're probably better off. So if you think about it, if I have a rectangle and that perimeter, so that perimeter is equal to, 100 centimeters. And of course, you might have a value here and a value here, but all of those four sides are going to add to 100 centimeters. Now, X is the width of the rectangle. So I'm going to call this X. Okay, now we need to sort of come up with some relationship. It says use the perimeter to write an expression for the length of the rectangle in terms of X. Well, we know that that perimeter is, we've got here would be X, here would be another X, and if you like, we can sort of say that if I was to subtract 2X from 100, that would actually give me this length here. Okay, so this would be, think about it, I've got 100, and if I take away 2X, that would be like these two here. So the rest of it would be 100 take away 2X. Well, if I divide that by 2, that's going to give me 50 minus X would be this one here. Let's go ahead and see. Let's check. If I add all of these up together, then I should be able to get 100. If I go 50 take X for one side, and I add the other side, 50 take X, and then I add 100, and then then I add x for the width and another x. You can see there when I add those up, we're going to get 100 minus x is minus 2x plus 2x. You can see there that's going to be our perimeter. So for the length of the rectangle in terms of x, so you can see I've just shown you that. So the length is equal to, we can say it's 50 take away x, all right, which is this guy here. Now it says write an equation for the area of the rectangle. Well, the area we know is length times width, and our length is what we've just come up with. That's 50 take away x, and our width is x. Now if I go ahead and expand that out, you could actually see that this is what we call this is a quadratic. 50 times x is 50x, and minus x times x is minus x squared. All right, so you can see that what we've got is my area is equal to 50x minus x squared. This is a quadratic. It says decide on the suitable values for x. Well, it would make sense that x, x really couldn't be 0, could it? Because if x equals 0, it would have no width. Another thing as well, if you were to throw in here, if you were to type in here, then, what's a suitable value for x there? Well, clearly x cannot equal 0. But also, if I was to do 50 take away x, then if this value was larger than 50, if this value is larger than 50, then I'm going to have a negative value. You can't have negative width, okay? And you can't have negative length as well. So I would probably a suitable range of values would be between, so let's say x would be between 0 but not inclusive, and also let's go to 50. If it's 51, well, 50 take 51 is negative 1. You can't get a negative length, can you? So what we can do is we can adjust the length and the width to actually give ourselves a maximal amount of area. It says use the graph to determine the maximum area that can be formed. Let's go ahead and sketch this. We've got this thing which I said is a quadratic parabola. Let's go ahead and sketch this now. Well, first of all, let's sketch that, and we're going to find where a equals 0, like the y-intercept. So the a-intercept is like the y. We'll let x equal 0. Now, of course, when you go ahead and sub that in, that's 50 times 0 minus 0 squared, which of course is just 0. So now I'm going to change that from a y to an a, and the x is there, that's fine. So it's going to be a graph which looks something like this. And it is going to turn, let's go ahead and find the x-intercepts. Okay, so when a is equal to 0, let's go ahead. Now we've got 50 take x times x. It's already been factorized by that, of course, so really we probably should leave it like this, but I guess you could have it this way too. Now, how does this equal 0? Well, this is equal to 0 if x is equal to 0, and also if x is equal to 50. Now, of course, let's go put those down. Let's go up in 10, 20, 30, 40, and 50. There you go. Let's go there. So, okay, I've got 0 and 50. And you notice that this is sort of a negative parabola. This thing here is a negative parabola. So it's going to sort of go up, and it's going to turn somewhere, and it's going to get down there. Now, basically, what this means is if I was to do this, then if I was to have x was 0, then that means that I'd have an area of 0. That really wouldn't make much sense, would it? If x is equal to 50, then the length would be 50 take x, 50 take 50 as 0. So you'd also get an area of 0. So we've got to find the sort of the optimal area somewhere between there. So as you can see, looking at this graph, halfway between the two intercepts, use the graph to determine the maximum area that can be formed. So that's going to be at this turning point. So that's going to be halfway, which you can see when x is equal to 25, halfway, let's find out what the area is equal to. Well, let's go ahead and sub it into our factorized form. Okay, let's go sub it into this guy over here. Okay, so you've got there that let's 50 take away 25, and then that would be times 25. Now 50 take 25 is 25. 25 times 25, you can use a calculator if you like, is 625 square, what is that, square centimeters, I think it is, centimeters. Okay, so what have we got? Well, what this is just told us that we've got a turning point at 25 and 625. Means that the what is the dimensions of the rectangle to achieve this maximum area? We'll get to that in a second. So you can see there that it appears as though there's a turning point, a maximum turning point at this point here. So what does that mean? It means that when x is equal to 25 centimeters, then my area is equal to 625 square centimeters. Now, what does that mean? Well, if x is 25, then in actual fact, now remember, a square is actually a type of rectangle. We said that this was 50 take away x, which is 25. So in actual fact, what is the dimensions of the rectangle? Well, a rectangle is still, a square is still a type of rectangle. So it's actually going to have the dimensions of this 25 and 25. It's actually going to be a square. So if you want to create the most area, if you were to cut out a piece of cardboard or something like that, then the way to get the most area by using less material is by doing a square. If you make it into a rectangle, you're going to get less area. So, all right. So as you can see, it's and look, this is a sort of a common style of question. You know, maximizing area. This sort of thing is actually pretty common when you're looking at these questions. All right, now it's time for you to try a similar sort of problem. So I've got this one here, okay, which is in your notes. So I'm going to pause this now, and I'd like you to pause this and actually have a go at yourself and have a look at the one that you've just seen. All right, I'm going to go through my solution in a second. So I'll pause now. I want you to have a go at this, please. It's very similar to the one we've just done. All right, now if you're struggling to get started on this, the first thing to do would be to draw your rectangle, okay? And it says that a piece of wire, we've got 80 centimeters to use. Now, if you think about it, if I go ahead and draw that, so let's draw that. We've got something like this again. We'll call this width x, which means that's also an x. And of course, when I add all of these things together, if you like, this thing here, if I subtract 80 away, or 2x, so we've got x here and x there, if I subtract that away, and then I divide by 2, that's going to give me this length here. So 80 take 2x, divide by 2 is 40 take away x, which means that we've got 40 take away x here, and 40 take away x here. All right, now that we've got a start, now let's see if you can do the rest. So I'm going to pause this again, and when you look up, it'll be the solution. So hopefully you've given this a go. All right, so I've sort of done this one with you. So for you, you can see there that we have the area is the width times the length, which is x times 40 minus x. Now we can leave it like that. This is expanded. This is, hopefully you can see, is a quadratic. It's a parabola, and it's a -1. Now, of course, once we go ahead and I want to find the x-intercepts, well, that's when a equals 0, so I want to find that. And you can see by the null factor law that x would have to equal 0, or x would have to equal 40. Now, of course, I mark those points, 1, 2, and we know that it's going to turn halfway between. So let's go ahead and find, well, we know that the turning point's at x equals 20. If we sub that in, that's going to give us the area of 400, which means that it's a maximal area. And that's going to result in the dimensions. As it turns out, once again, it's going to be a square. 20 times 20 gives us 400, and that means that the length is 20 and the width is 20. Once again, this sort of question is pretty common. So you do need to practice a few of these ones sort of in particular, because it is a pretty sort of common question that will ask you in your exam too, which is sort of the more wordy exam, and you also have a calculator. So look, we'll also go through how to use the calculator and stuff, and you should probably practice. Just note though, with the calculator, you can only put in, y in terms of x. So if you've got d's and h's, I still want you to sub them in as y's and x's and in your calculator. Of course, you'll need to practice a lot of these questions in your work lesson as well. So you'll have a good period to do that. All right, so you'll need to practice those. In particular, you want to make sure that you if you just did 2 of them, you probably just want to do those 2 to start with. All right, that's it for me. Hopefully you've sort of filled out your notes along the way, and hopefully you've got plenty of questions, and you really need to try these. If you think that after doing 2 or 3 with you, you'll need to do 2 or 3 yourself. All right, all the best. See you in class.